Now, ready all of you? Inform your friends to join very fast. Okay. Now, so first, before we take today's topic, first on the screen, everyone, a whiteboard is shown on the screen, right?
Yes,
Digital
yes,
whiteboard.
sir.
See, first listen. So what I am saying in our subject, if I draw one simple circle, it is a conductor. We should assume it is a conductor. Conductor means what? Anyone practically you tell me? Because one day one student has asked the question, whether everybody know or not. Conductor means what? The object in which current flows. The object in which or through which current flows. Okay. In our brain, we should imagine we are having the copper rod, copper material. Okay. So copper is nothing but the conductor. So copper, inside the copper, current will flow. Okay. So if I say current is flowing through the conductor, you can draw in this manner. Current is flowing through the conductor means this is the symbol. This cross mark indicates that this is current carrying the conductor. Current carrying conductor or current is flowing through the conductor. Or you can draw in this manner, the conductor, a copper rod, we can draw. I'll show you when you are supposed to draw. Okay, but today's derivation will be tough. There are two derivations we will see which are very much important. Okay, only 25 are there. Inform your friends to join fast. Now, this is the conductor. Now, all of you listen here. This is north pole of a magnet and this is the south pole. Okay, always magnetic energy or magnetic lines of force, they travel from north pole to south pole. Now, I am taking one conductor, okay, and current is flowing through the conductor. Let us say current is I. When current carrying conductor, listen my word carefully, when current carrying conductor is placed in the presence of magnetic field, what happens to this conductor? Anyone? So what will happen to this conductor means this conductor rotates or moves automatically. It experiences a force. That is, this conductor starts to rotate. So what is the statement? Anyone, can you tell? Whenever a current carrying conductor is placed in the presence of magnetic field, that conductor experiences a force. Therefore, so how it is possible, we'll see with the practical videos, experiment videos, and the derivation also. Okay, now you see all of you. What is our topic? So whenever a conductor, current carrying conductor is placed in the presence of magnetic field, that conductor starts to rotate or move from one place to another place. That is the topic. Now you keep the heading, all of you, in your notes. All students, I'll tell you what is heading. Now you see what you are able to see on the screen. Read out one student.
Force on a current.
Carrying
Force on
conductor
current carrying conductor in a magnetic field.
See, force means what? That conductor is rotating, that conductor moves, therefore we say force. So all of you keep the heading. This is the derivation. So whatever I said, you directly put it in your notes. It works a lot. So what is the question you will get directly from this unit means force on a current carrying conductor in a magnetic field. Okay, keep the heading please, everyone. Write in your notes. Sir, what is this topic? Show me practically. Okay, in your house, okay, fan. Inside the fan, we are having the copper wire. Everybody know. When you turn on the switch, what's going to happen? Current flows through the copper wire, which is present inside the fan. So that fan is called current carrying conductor. Current carrying conductor means what? The current flowing through the copper wire, which is placed inside the fan. Tell me one more example. Now, after a certain period of time, what's going to happen to the fan? Anyone tell me? When you switch on the fan, current flows through the copper wire, which is present inside the fan. Okay, then after a certain time, what will happen? Fan starts to
Rotate.
That means fan is experiencing a force. Now, as an engineer, we should explain, okay, fan is rotating. So mathematically, we have to explain what is the mathematical formula and what is the speed we are supposed to explain. That is what our subject. Now, one more example. MIXI, all of you tell me. MIXI is what you are able to understand. When you turn on the MIXI is called current carrying conductor. All of you. So current carrying conductor means current is flowing through the MIXI, which has got the copper wire. And then what happens to the MIXI then? MIXI is static or it is rotating?
Rotating.
Rotating. Therefore, now we say when any object is rotating means it is moving. So technically we say force on a current carrying conductor. Force means mechanically it is vibrating or it is moving. One more example, anyone tell me? One more example. In your
Coolers.
house. Cooler, very good. Cooler is current carrying conductor. Boring machine, that water machine is current carrying conductor. Yes or no? All of you. Right. Fridge also, it will generate this sound. Yes or no? Vibrate. Fridge, when you turn
Yes,
on
sir.
automatically.
Yes, sir.
Yes, sir.
That the fridge also current flows. They are called current carrying conductor. So everything works with this concept. Now, as an engineer, we should explain what is the mathematical equations. Okay. Now you see. So first, I would like to show you before we do any derivation. This experiment, anybody has done? Cardboard we have to take, place the iron fillings, and when supply is given, they will be arranged in proper shape. Yesterday we have seen the proof that magnetic energy is really existing. Now you see today's class. Now all of you, all students, now we are starting. Yes. What you are able to see on the screen? Force on a current carrying conductor. So mathematically we have to give the explanation. All of you see here. What is this silver color? Anyone tell me? Let us consider a conductor. In what way we have to write in the examination? Let us consider a conductor. Conductor has got two ends. Let us say A and B. Okay, conductor is taken. Okay, no need to have the size A and B. So conductor means copper rod, copper wire you purchase from the electric shop. Copper, that's all. Never imagine what is a conductor in that manner. Copper is the example of the conductor. Okay, so copper coins also there. You know, all of you, the coins, the 1 rupee coin. Now we are having aluminum. So initially we used to have in copper. Okay, copper is the best for the health also. People used to say that drink the water inside the copper glass only. That is very good for the health. You know that one. Any water filter is having the copper right now. Water filters also. Okay, now I am having one conductor. What I have to do? I have to pass the current through the conductor. See, all of you, I am taking the stand now. And the conductor is placed, is connected to the stand. It is in the air. All of you, is it visible or not? All of you. Conductor.
Yes, sir.
Okay, now what
Yes, sir.
I have to pass the current through the conductor. How to pass the current through the conductor? Tell me anyone. This is the conductor. What I have to do? How to pass the current? From our hand we will get the current? No. We have to connect. Tell me fast.
Battery.
Battery. Okay. Now what I am saying, conductor is placed in the presence of magnetic field. Means magnet we are placing. Magnetic energy will move from north pole to south pole. Okay. So now I have to pass the current through the conductor. So to pass that one, what is my next component? I have to take the battery. Okay, these are nothing but copper wire once again. Conductor, copper rod to have maximum current, copper rods. Now you can see the batteries came into the picture. This is the switch, all of you. Okay, now till now it is ordinary conductor. Now I am turning on the switch. When the switch is on, current flows from the battery to the conductor. Now the current is flowing. You can see the conductor. Yes. What you have observed, anyone? Once again, I'll forward this one. You see, when current flows through the conductor, that conductor changes its position automatically. It experiences a force. You see the conductor now. Current is flowing. Yes. All of you observed that change, movement in the conductor? All students?
Yes, sir.
Yes, sir.
That means whenever a current carrying conductor is placed in the presence of magnetic field, that conductor starts to move or it experiences force. So mathematical formula we are supposed to explain. So once again it is moving. Okay. So what next I'll show you. Now all of you, yes, I'll explain this one also. So conductor is moving. It is explained by the Fleming's left hand rule. We'll discuss that one with the derivation also. Now all of you see this one. One second. Yes, all of you see, we have done the practical experiment and we are showing you can try it in your house also by purchasing these components. Now you see. So what I have done, I have taken the battery. You can see the magnet. Magnet is visible, all of you, new video.
Yes, sir.
Yes,
So
sir.
real magnet is taken and this is the copper rod, small copper rod I have taken, and it is placed under the influence of the magnet. Magnetic energy we cannot see with our eyes. It is kept in the open air. Okay. So this is the copper rod, copper material. Okay. And it is again connected to the wires. And these wires are connected to the battery. Now we will see whether it will deflect or not. This is the copper wire again which is connected to the copper rod for the support, and this wire which is connected to the copper conductor, that is the conductor, it is connected to the battery negative terminal and positive terminal because current has to come out from the battery. Now you see we have done the connection here. This copper small rod, copper material is connected once again to the copper wires and then to the battery. Stand support we have taken. Battery you can see negative terminal. Okay, and next we are having the positive terminal here. Okay, now I will turn on the switch. When the switch is on, then current flows through the conductor, copper rod. Okay, now I'm turning on the switch, all of you. Okay, now I'm just turning on the switch. Now you see this is the initial position. When switch is on, then magnetic energy will make that conductor to move from one place to another place. Yes, we are showing the magnetic energy here. So this is the switch. Let us turn on the switch. Get ready, see carefully all of you. Yes. Be ready, all of you. Watch carefully. Yes. Conductor has deflection towards right. Yes or no, all of you. You can see when the switch is on,
Yes, sir.
the current flows within fraction of seconds. Immediately the conductor starts to move. That means what is our topic? Force on the conductor placed in the presence of magnetic field. So whenever current carrying conductor, when I turn on the switch, this conductor has become current carrying conductor. Even current carrying conductor is placed in the magnetic field, that conductor experiences a force, means it starts to move from one place to another place. So on this concept only the fan is working, the mixie is working. Okay, so now all the students, what you have to draw, how to explain in the examination. Now you see I am drawing on the digital whiteboard. Okay, all the students, now you all of you draw along with me. So first what we have to draw in the examination, first certain parallel horizontal lines. Draw along with me all of you. First horizontal lines we are drawing. Okay, 4 horizontal lines you can take, and these horizontal lines are having certain arrow mark, that means direction of the magnetic field. So we call this one as the magnetic field. All of you can write there, magnetic field. Now all of you tell me, I am giving you certain magnetic field, imagine. Okay, and you are throwing that magnetic field on one surface, and this magnetic field is occupying certain space. Then that concept, now the magnetic field is called as the, I am giving the int. What do you mean by the word B in our subject?
Magnetic flux density.
Density. That means I am giving you certain magnetic energy, and I am asking you to store that or place that magnetic energy inside one cup. Then we call that magnetic energy as magnetic field density or magnetic flux density. Magnetic field, another name is flux. So I call this one as, I draw 4 parallel lines and I am keeping the arrow mark. This is the direction of magnetic field. And if I write here B, everyone will understand that this is magnetic field density. That is, magnetic energy is occupying certain space. Here we are having the magnetic energy. Okay, right. Now, okay, draw this diagram, all of you, very fast. Examiner will see the concept in what way you are drawing. Okay. Now, what is our concept? What is our topic name? Force on the current carrying conductor placed in the magnetic field. Okay. Now, I am taking one conductor. Now, all of you see here. Let us say I am taking one conductor. First, I am drawing like this. And this is your surface. Okay. What is the angle between these two? Anyone tell me? Angle is how much? 0. Because both are horizontal only. Now you tell me what is the angle. This is the surface and this is the conductor. What is the angle?
90
degrees.
90 degrees.
So now we say I am placing the conductor in the presence of magnetic field, current carrying conductor. So I am just drawing in this manner. Examination also you have to draw. Okay, sorry. You just draw in this manner. 1 second. Let me erase this extra part. Okay. Okay. So I want to show the conductor. See, conductor, copper rod. You draw straight. Okay. If I'm having the curve here. So only the end points we are showing in this manner. Or simply 2 parallel lines, closing that parallel lines you can draw. This is the conductor. Okay. Conductor has got certain length. Length is nothing but represented by L. So drawing subject you are having now, all of you, right now. So we are explaining this representation is explaining what is the size. Draw along with me. Okay, all of you, this is the length of the conductor. Okay, now, so current is flowing through the conductor. Now, what is the angle here? Let us call this the magnetic lane, magnetic path. So angle how much? Anyone tell me? So we don't know the exact angle. So I assume the angle between the conductor and this magnetic axis as theta.
Theta.
Okay, you draw there. Theta clearly you draw, all of you. Okay, theta is the angle between the conductor and this magnetic axis. So now, what type of conductor we have to place? Current carrying conductor. We should show that current is flowing through the conductor. All of you just draw these horizontal lines. You can keep the arrow mark also. So inside the conductor, these lines are flowing. These are representing that current, and now I represent by current I. Understood, all of you? This exact diagram, I'll give you the material also. I'll show you that PDF. Okay. All of you finish this diagram, simple diagram. Okay.
Yes,
finished, all of you. Now, so this is theta. Now you say, now you have seen practically when current carrying conductor is placed in the presence of magnetic field, it starts to move. Its force is created. So how much force? So F is equal to, formula you have to remember from today onwards. F is equal to, conductor is rotating or conductor is moving. Yes, 57, you got the question? Raise your hand. Yes, any question?
No, sir.
Okay, right. So conductor is moving here. Conductor is rotating. So now we say conductor is rotating because of which energy? Anyone tell me? Magnetic. So we write magnetic energy with the high strength magnetic flux density B. Next, current is flowing through the conductor. Yes or no? If no current is flowing, conductor cannot move. Therefore, we write B into I. BI. Okay. Next, the length of the conductor. Now you see, all of you, from the trigonometric mathematics, see, if any object is vertically placed, okay, then which trigonometric function I can take directly? Means sine. If an object is horizontally placed, then you can take directly the cos. Okay, sine and cos. Sine, when we have to take, if any object is placed vertically at certain angle, so we are just taking B into I into L into sine. You write there sine theta. Okay, and the force is directly proportional, all of you. First, force is directly proportional, depends on magnetic field density or magnetic flux density, I current, L and sine theta. So F is equal to certain constant. So finished all of you this part. So now you see we'll come
Yes,
to this
sir.
one. Yeah, now we'll come to this particular practical. Now one new document you are able to see on the screen, PDF, all of you.
Yes, sir.
Okay.
Yes, sir.
Okay,
Yes.
all of you, clarity might be there. So no need to write this paragraph, this top paragraph here. So what is the topic we have to study? Force on a conductor in magnetic field when it is placed in the presence of magnetic field. Force on a conductor. Okay. Now diagram, all of you understood the same diagram what we have drawn. Yes sir, all of you. The conductor, instead of dotted lines, here we have shown the arrow mark which is representing current. And what you are having to the right side? Anyone read out this?
Magnetic flux density.
And the theta. Okay, length. So what is the explanation? B is magnetic flux density. Units are Weber. Magnetic flux means Weber per meter square. Let I be the current. Okay, length of the, you can write only the length. Effective length means total length. Length of the conductor and the angle between the conductor and magnetic field. So directly what's going to happen? What we are supposed to write? Read out anyone here? Force experienced by the conductor is directly proportional to, read out this, is it visible or not? BIL sine theta, right? F is directly proportional to B into I into L sine theta. Units are newtons. No need to write newtons there. You write this one. Force unit is Newton. That's why they have written. And F is equal to certain constant into BIL sine theta. So your fan is rotating. So you are studying the engineering. So what is the mechanism? How the fan is rotating? What is the force experienced by the fan? Means F is equal to K into BIL sine theta. Understood all of you? Yes, the mixing. So today onwards, force experienced by a conductor in magnetic field. What is the force experienced by the conductor in magnetic field? Tell me anyone. BIL sine theta. F is equal to BIL sine theta. It is clear all of you? Okay. All students. F is equal to BIL sine theta. So this PDF I will share soon after the class. The same expression you can diagram, and this line is important. Okay. So now we move. If it is clear, I will just go for the next concept. Anyone? All of you. Is it clear or not?
Yes, sir.
No need to write all the statements, only the formula, the diagram. Okay. Now let us go for the next. Okay, I am giving you two conductors now. Okay. Now I'm telling one thing. I'll see how many of you believe or not. So I am giving you two conductors. Okay. New screen is visible now, all of you.
Yes, sir. Yes, sir.
Now I am asking one thing. Can you do or not? You tell me this one. I am giving you two conductors, two copper rods. Okay. Now, without touching them, you see that you are bending both the things like this. Can you do that one? In this shape, both should bend towards each other without touching. Tell me anyone, can you do that one or not? I am giving you two conductors and you are not supposed to touch those conductors. Without touching, I want to see both the conductors are in the bend condition. That is force, both are attracting, coming close to each other. Okay, we'll see how it is done. Okay, now all of you.
By using magnet we can do, sir.
Very good. By using magnetic field. What is your roll number? Very good.
37.
37. Very good. Right. So, okay, now let us discuss this particular concept. So, what is our next topic? Okay. So, all of you, now, all of you keep your left hand like this on this, how it is shown on the screen. Left hand. Okay. Ready, all of you? As it is, you keep left hand.
Yes,
So,
sir.
10th class, you have done this?
Yes, sir, we done.
You have done no?
Yes,
So,
sir.
the thumb represents force on the
Force.
conductor, motion of the conductor. The first finger or the forefinger represents the magnetic field. Magnetic field, B we are writing. And the direction of the current is given by the central finger. Okay. This is given by the Fleming's left hand rule. So, in what way the force, we cannot see the magnetic field, but we can experience. Yesterday we have seen iron fillings are arranged in proper direction. Okay, now you see One video first, then you'll understand. So what I'm saying, you see the video first, all of you. Yes, I am giving you two conductors. Video is visible in all of you, green color conductors.
Yes,
Yes,
sir.
sir.
I am giving you two conductors. Now, what we have to do, what is our topic also we'll discuss here. Okay, what is the topic? So what is the force between two conductors, two parallel conductors? So you can see positive means current is flowing. So let us consider two conductors, A and B. Okay, and current flowing through the conductors is I1 and I2. So without touching them, you can create the bend condition by passing the current and creating magnetic field. If any person is asking any question, you say current flows, magnetic field is created. We can do anything. Okay. So current is flowing now. Current is flowing through both the conductors. You can see the direction. What happens? Anyone tell me? Magnetic energy is created in which shape? Circular shape across the conductor. So when currents are entering into the conductor in the same direction, then what's going to happen? Two magnetic energies will be created. These two magnetic fields or magnetic energy will make the conductors to attract each other. Therefore, the conductors start to move towards each other. You can see now. Yes, all of you observed this one. Attraction force. All students.
Yes, sir.
So now you remember what is our concept. Okay, it is by seeing it looks like it is simple, but we have to explain with the diagram in the examination. So when with the equations also. So two conductors are placed in parallel. When current flows in the same direction, then both the conductors are attracting each other because of magnetic field. Now you see once again the second part. Now once again I have taken two conductors. Now you see current direction is changed. All of you see this is positive here and here we are having positive. So current comes in this direction. One current comes from the top to bottom and we are from lower to upper end. You can see current flowing in opposite direction. Yes or no? So when two currents are flowing in opposite direction, so what's going to happen? Two magnetic fields will be created. Both will repel each other now. So because of repulsive force, what's going to happen? The conductors will move away from each other. So repulsive force is created. Yes, now you might have observed. So this proof we are supposed to explain with equation. So the topic will see. So what is our explanation, all of you? When two parallel conductors we are having, when the current flow is in same direction, both will attract. So I will show you. All of you, what I have written here? Read out anyone? Same direction of currents. Which force?
Attraction force.
Attraction force. Attraction.
Opposite direction of currents.
Repulsion force.
Repulsive
Okay.
force.
So what is our topic? Now you see for today's class. All of you keep that thing. 1 second. 1 second. Topic name you write first. Yes, all of you. What is our next important? You'll get directly in the examination. Force between, keep that in all of you. Okay. Force between two long parallel conductors. Okay, two long parallel conductors. So first, all of you see the explanation. Before you study this one, now, yes, please mute everyone. Before we study, you are supposed to start reading certain basics. Okay. So all of you remember this diagram now, all of you. H stands for what? Any student tell me? H stands for magnetic intensity, strength. H is equal to Ni by L. H is equal to I by 2 pi R if you are having a circular conductor. Okay. Area of the circle is how much? Anyone tell me? 10th class you have studied now?
Pi r square.
Pi r square.
Pi r square.
Okay.
Pi r
Similarly,
square.
we are having the based upon the conductor 2 pi r. Okay. It is radius. So H is also equal to I by 2 pi r, magnetic field strength. Now all of you, in order to understand that parallel conductor's force, if two conductors are given and they are placed in parallel, they are attracted, they are repulsive force is present between them. In order to understand that one, first you have to study the simple basic. Just a minute, give me the time. All right, let me share this one. Okay, so all students, just a second. You are supposed to study the simple definition first. Anyone tell me what is permittivity? Permittivity. All of you. See on the screen, all the students. What is the first definition we are having? Permittivity. Is visible or not? Visible? All of you. The screen is visible or not now?
Yes, sir.
Okay, okay. Now,
Yes.
see, all of you don't get confused. We got two definitions, permittivity and permeability. So when I say magnetic energy, we are supposed to study permeability. When I say electric charge, static electricity, permittivity. So what is the definition of permeability? You read out, anyone student? Ability of a material to allow magnetic lines of force, that is magnetic energy, to pass through it is called permeability. Now you tell me, human body can pass magnetic energy through it or not? Human being.
Yes,
No.
Answer is
Yes,
yes.
sir.
Magnetic energy also, it can be able to pass through the human body. Magnetic energy. See, when, sir, what is the proof? My body is creating magnetic energy or not? Show me the proof. Means all of you, if you are not talking with, if you are not talking maximum, if you are not concentrating on unnecessary things, okay, and if you are completely focused to a one particular topic, okay, then your brain generates the magnetic waves, electromagnetic waves. All of you remember this word, what I am telling right now. Few people can walk on the water. You know that one? Few people,
Yes.
they can walk on the water. So how they are able to walk on the water means, if you are targeted, if you are focusing on only one particular task, not discussing unnecessary things, not seeing the unnecessary things, your brain is focused, then your brain generates electric field and magnetic field. Electric and magnetic field will make the human body very much light, and you can walk on the water also. And one more thing, few people without touching their hand, without using their hands, they can move the stone also from one place to another place. I will show the video also, that one. So your brain also generates electric field and magnetic field. So ability of a material to allow magnetic lines of force to pass through it is called the permeability. So which materials will pass the current? Copper, aluminum. Which materials will pass the magnetic energy? Remember all of you, steel, iron. Steel material and iron. Iron is the best conductor of magnetic energy. So what is permeability, all of you? Ability of a material to allow magnetic lines of force to pass through it, that is to allow magnetic energy to pass through it. Which material will allow maximum magnetic energy? Tell me all of you. Iron and steel. Iron and steel. Okay, silicon steel. All of you, you see, you are nowadays we are using the silicon steel. Okay, we'll come to that point. So this permeability is represented by which letter? Everything we'll see now. Definition. Then you will understand the entire that force, the two conductors concept. All of you, now you see this material will be given magnetic permeability. What is the symbol? This one, U only you can say. All of you, this symbol is nothing but U. Mathematically, what is the definition? U is equal to B by H. Forget about the units. What is the formula? Permeability definition I have given. Anyone tell me what is the definition of permeability? Ability of a material to pass magnetic energy through it. Okay. U is equal to B by H, the formula relation. B means, you know, flux density, H is intensity. Okay. Now, absolute permeability. Permeability is divided into two types. Absolute permeability in free space, in air. Magnetic energy can also pass through the air, but very less amount. So how much magnetic energy is passing through the air? What is the permeability of air means? You see all of you. Permeability of free space. How much? This value? This value you have to remember. 4 pi. 4 into 3.17 pi means. Okay. 4 into 10 power minus 7 Henry per meter units are. Remember this point. Okay. And now, yes. Now, absolute permeability of, you remember this formula, all of you? Permeability U is equal to U naught into UR. U naught is nothing but absolute permeability. That means permeability of different materials. Now you see what is relative permeability. Relative permeability of magnetic material is represented by UR. It is the ratio of absolute permeability. Okay. So air, copper, wood, glass, plastic. Every object has got different materials. So what is the permeability, all of you? It is represented by U. U is equal to U naught into UR, and U is equal to, what is the next definition which is important to us? U is equal to B by H. So finally, can I write? No, B is equal to U into H. Yes or no, all of you? What is the final expression you see, all of you? What is the final expression? Read out this one. B is also equal to U into
U into H.
That means I am giving you iron material. Okay. Magnetic energy is present. Okay. B. What is the strength? H. So relation is B is equal to U into H. This formula we require. Okay. Right. First be ready with this formula. Now you see, all of you, how to explain the two conductors. That material also I'll give you. But you see. What is the topic? Force between two parallel conductors. What is the new topic, all of you? Force between two parallel conductors. Now this is the toughest one. Okay, 1 minute time is there, but I will explain next class also, but you listen. I will release one video, explanation video. Okay, this one. Force between two parallel conductors. Now you see how to explain. Let us consider two conductors. AB is the first conductor, CD is the second conductor. Okay. Now, first, imagine that current is only flowing through the conductor AB. Both are separated by distance A. Okay, current flowing through the conductor 1 is I1 and current flowing through the conductor 2 is I2. Please mute. 56, mute yourself. Current flowing through I1 and I2. AB, current I1 is flowing through AB and I2 is flowing through CD. So when current flows, what will happen? Anyone tell me? Now the current is flowing. All the students, now listen in a simple manner. Let us consider two conductors. Current is flowing through the conductor AB. It creates magnetic energy. That magnetic energy increases. Now that magnetic energy is also called as magnetic field density or magnetic flux density. Now second conductor will be experiencing that magnetic energy. So these formulas are, what are these formulas means? What is the formula for B? Anyone tell me? B is equal to U into H. U is equal to U naught into UR. What is the formula for H? I by 2 pi R. Just now I have shown you. So B can also be written like this. I'll explain these formulas. Okay. So I'll do one thing. Or I will release one video of this topic or the force between two parallel conductors. Is it clear, all of you? How we are getting these expressions? Then that video you can see and you can write the same explanation. After the class, PDFs will be sent to you.